Welcome to this video. Will Marty make it back to the future? So, I like Back to the Future. I'm an 80s kid. It's a great movie. If you haven't seen it, I highly recommend it. So we have for our scenario today, Marty trying to get back to the future. So we have a little story here about DeLorean sports cars, which is the car that Marty uses to get back to the future. After accelerating for 20 seconds, the DeLorean sports car has a wide range of speeds that it can achieve depending on traction. The distribution of the speed follows an approximately normal distribution with a mean of 80 miles per hour and a standard deviation of 7.7 miles per hour. So the first thing I need you to do is to label the appropriate values on the normal distribution, and then I want you to go through question 5 on the front, and I want you to pause the video, do through question 5, then restart the video to see. All right, let's see how you did. Hopefully you remember to include your normal curve with the mean and the standard deviation. So our notation is N is for normal, mean and standard deviation. You need to have that because you can completely describe the normal distribution from the mean and standard deviation. I went ahead and labeled in my percentages in each one of these. I have my mean of 80, and then going to the right, I added 7.7. Going to the left, I subtracted 7.7 each time, and this should be what yours looks like. Okay? So question 1, what percentage of the runs will give a speed greater than 87.7? So here's 87.7. So we're talking about the amount above it, greater than it. So that would be 13.5 plus 2.35 plus 0.15 equals 16%. Okay. How about what percentage of the runs will give the DeLorean a speed between 64.6 miles per hour, which is right here, and 87.7 miles per hour, which is right there. So you just want to add those up. 13.5 plus 34 plus 34 equals 81.5%. Question 4. What percentage of the runs will give the DeLorean a speed of less than 64.6? So less than 64.6 is those two sections. So when I add them up, I get 2.5%. And then question 5. Bum, bum, bum. All right, I bet you your paper looks an awful lot like my paper because you got to question 5 and you looked and you're like, the number's not there. You might have tried a couple different things, so let's talk our way through it here. First, let me tell you why. The last lesson was about the empirical rule. These guys right here, they follow the empirical rule. Okay? That rule, to help remind you, is the 68, 95, 99.7 rule. Okay? However, that only works when you're going to whole standard deviation lines. What happens if we're falling between the standard deviation lines, like this question asked? This question asked for a speed less than 68.45. So 68.45 is somewhere in here. And if you actually tried it, you found out it is exactly in the middle between 64.6 and 72.3. So here is our 68.45. All right. And so if I go up, it was the exact halfway middle. I'm talking about kind of this area. What is that percentage of the area? Well, half of 13.5 would be 6.75, but that's not going to work because if we look, this section that I highlighted is not the same size as the section that I didn't highlight. That's the problem with a curve, okay? So we can't just estimate what half of it would be. So we're just going to cross that off. And here's what we're going to do. couple days ago, we talked about z-scores. We're going to have some z-scores come in. So let me remind you, a z-score is some value of interest minus the mean divided by your standard deviation. All right? So we were finding how many standard deviations above and below the mean already. We've already done this. So when it does not fall, when the question I'm asking does not fall on one of these whole standard deviation lines, you need to do a z-score. You can do a z-score for the whole standard deviation line too. You'll get approximately the same answer. So our empirical rule is really a cheat. It's a shortcut. I don't often show you shortcuts, but that's a very common one. So I wanted you to be able to use it. But what happens if we don't have the shortcut available to us? So the value of interest was 68.45. So we're going to say 68.45 minus the mean, which is 80, divided by the standard deviation, which was 7.7. And when you calculate that out, you get negative 1.5. So it's 1.5 standard deviations below the mean. Well, we already knew that because we said it was right in the middle here. That's one whole standard deviation and half of the other. All right, so what does this mean? I want you to pause the video and I want you to find your packet that I gave you in the first couple days of school, your resource packet. It has the formula sheet in it. And I want you to turn just past the formula sheet. And there is something in that packet. Mine is blue, yours will not be blue. It's called Table A. It's kind of hard to see in the shading. Table A, Standard Normal Probabilities. So I want you to pause the video and grab that piece of paper and then come back. All right, so looking at this table, there are two sides to it. You have one side that has a bunch of negative numbers on it down the left-hand column. And when you flip it over, you have a table that, notice it says Z at the top, and it's got a bunch of positive numbers down the left-hand side. So what this left-hand column is, it's the very beginning of a z-score. It's the first two digits, and we only ever use 3 digits when we describe a z-score. You've got a number in the 1 spot, a decimal, a number in the 10th spot, and a number in the 100th spot. Okay, so when I look at my z-score here, I got a number in the 1 spot, a decimal, a number in the 10 spot, and then I'll just put a 0 here. That's my third number. I need to find this z-score, and this table will tell me the percentile or the percentage of people below that number. Okay, so negative, we want to flip to the negative side. The first two numbers are 1.5. So I want you to find negative 1.5 on here. Here it is right there. And then the next number tells you what column. We have the 0 column, 1 column, 2 column, all the way up to 9 column. Well, our next number was 0. So we have negative 1.5, 0. And this 0.0668. Okay, so I want you to write area equals 0.0668. So what that is telling us is this is the percentile for 68.45 or 6.68% of the speeds are less than or equal to 68.45. Okay? A couple things I want you to remember here. One thing I want you to remember is that the area under the curve equals 1. Okay? So if it's 0.0668 to the lower end, if you do 1 minus that, it's going to tell you the other end. But our table, when you read it, right up here, it shows you it's only telling you the lower shading. Okay? So it's a percentile, so it's always talking about from where you're talking about and below, because that's the definition. All right, so let's see here. We had 6.68% of the speeds are below 68.45. just want to do a quick review. What is a z-score of negative 1.5 mean? It means a speed of 68.45 miles per hour, there's our context, is 1.5 standard deviations below the mean. All right, so we used table A to find this value. All right, and the reason we had to do that is if you're not going to fall onto 1 standard deviation, 2 standard deviations, or 3 standard deviations, the empirical rule does not work here. On partial standard deviations. All right. So that was kind of a lot. I lulled you into a sense of security because we've got this easy stuff and you're like, yes, so simple. This is more likely what you're going to see in having to do it this way. So let's flip this over and take a look at the back. All right, so question 6 wants to know what percentage of the runs will give the DeLorean a speed greater than 85 miles per hour. Even if I don't say this, I always mean it. Show your works. So the first thing we're going to need to do is we are going to need to draw a normal curve. Okay, from the front, we know that our mean was 80, and we wanted to say 87.7. We want to include our notation. Right now, that's all you need to draw. What does it ask? It says, what percentage of the DeLorean speeds are greater than 85 miles per hour? So 85 miles per hour is over here to the right somewhere. So I'm just going to draw a line, and I'm going to label it 85 because that's the score I'm interested in, and it said greater than that. So I want to know this percentage here. Okay? So to do this, I need to be able to use table A. In order to use table A, I need to have a standardized score or a z-score. So I want to redraw this. I'm going to try and line them up to help you kind of see. Okay. Our mean now, remember, if we're on a standardized score, the mean is always 0 and the standard deviation is 1. So the mean is 0. And I have this number here. I don't know what it is. Let's find the z-score. So we have a z-score. The score of interest is 85 minus the mean divided by the standard deviations. And when it's calculated out, I get a z-score of 0.65. So I'm just going to put 0.65 right here. And I'm still talking about greater than this value. So it's not even 1 standard deviation above the mean. All right? So let's see what we've got. I'm going to remind you here that our total area under the curve is 1. Okay? So take your table A. 0.65 is a positive value, so make sure you flip to the positive side. And we're going to say 0.6 because our first number is really 0.6. And then we need to go over to the column that has a 5 at the top, the 0.05. So there's 0, 1, 2, 3, 4, 5. Okay? And that value is 0.742. So I'm just going to write area equals 0.7422. Now, before we let's think about this. I am talking about from less than 1 standard deviation above the mean and up. This answer says it's 74%. Does that seem right to you? Because this mean is 50% above and 50% below. So I can't be way out here and have 74% above. This is where the shading comes in to remind you. It's always from the line to the left, always. So the 0.7422 is actually over here. So how do I find that amount? Well, the total area is 1. So I'm just going to say 1 minus 0.7422, and I'm going to get 25.78. So I got 0.2578, and I just kind of converted it already. So what percentage of the scores will be greater than 85 miles per hour? 25.78% of them. Okay, that's your final answer. Now, a couple things I want to say here for full credit. So you know what I'm looking for when I'm grading these. Okay. I want to make sure you have the unstandardized picture. This is unstandardized. Because it uses the mean as given. So I want the unstandardized picture. With the notation, mean and standard deviation, and shading. Okay. 2, I want the standardized picture, which is this one. Standardized means you got a z-score. And once you have a z-score, you have a mean of 0 and a standard deviation of 1. With your n, and this will always be 0, 1, because that's just the case. We already know the mean is always 0 and the standard deviation is always 1. And shading. All right. The third thing I want, we're going to kind of come into our other area here. Sorry about that. I want the z-score formula. And calculations. I want everything plugged in. I want to see it. And then the last thing I need to see is your final answer. All right, so this is kind of what I'm looking for. So what I want you to do is I want you to pause the video, and I want you to get this next one set up, and then unpause the video and see how you've done so far. All right, let's see how you did. So I have my 2 drawings here. I have my unstandardized, and it did ask about 2 scores between 70 and 95, okay? So 70 is somewhere to the left of 80, so I just drew where 70 was. 95 is somewhere to the right of 80, so I drew it there. And I want to know about in between, okay? So then I did my standardized curve. I've got it centered at 0. I don't have my z-scores yet. I need to find 2 z-scores here, one for 70 and one for 95. So let's try that. So we have z-score equals 70 minus 80 divided by 7.7. And when I did that, I got negative 1.3. I'll stick a 0 on there, so I have 2 decimal places. So this left-hand score is negative 1.30. And for my other z-score, I had 95 minus 80 divided by 7.7. And I got a z-score of 1.95. So that is this z-score right here, almost 2 standard deviations above the mean. All right, now what do you do? Okay, well before, when we got our z-score, we could look up an area. So here's what we're going to do. We're going to look up an area for this. I'm going to say area equals negative 1.30. So I have negative 1.3 0 is 0.0968. And positive 1.95. So I go to 1.9. And then I go across to the fifth column. And I got, it's kind of hard to see with the shade there, 0.9744. Okay, so let me kind of take a look here. The area, remember, the shading is always to the left. So this is showing this shading. And this one is showing this shading. Do you see how they overlapped right there? What you need to do is you need to take the larger area minus the smaller area, and that will take care of that overlap. And I got, when I did that, I got 0.8776. So 87.76% of the speeds are between 70 and 95 miles per hour. All right, so hopefully you're kind of starting to see how we're doing here. One last one, and I'm going to ask it a slightly different way. Marty wants his last run to be in the top 15% of all possible speeds. What speed does he need to achieve this top 15%? So before I was asking about a speed in particular. Okay, so sometimes let's draw the picture. I like to draw the picture first, and I think it helps you kind of think about what you got to do. So we're at 80. The top 15% means 85% or below. Well, the 85th percentile is going to be over here. So I want 15% to be here, and that's going to be 85%. What I don't know is that number right there. Okay, so in our formula, we have a z-score is some value minus the mean divided by the standard deviation. All right, well, we already don't know the value. I'll put this in a different color so it's a little easier to see. We already don't know that. We do know this, so we have x minus 80 divided by 7.7. So I have two unknowns right now. I don't know the standard deviation line, and I don't know the value. Well, how do you handle that? I can actually find the standard deviation line because I know this percentage. And more importantly, I know this percentage. This is 85%, which would be written as 0.8500. Okay? So if I look at my table of values, and I get as close to 0.8500 as I can get. So here's some there's 0.8508. There is 0.8485. That's 15 below. This is only 8 above. So I'm going to take this number right here. This is closer to 0.8500. What is the z-score for that? I'm going to follow it out. It's 1.04. So I actually know the z-score. The z-score is 1.04 equals some score minus 80 divided by 7.7. So from here, it's really an algebra problem. So pause the video and finish this out and see how you do. Bye.